My name is Logan Schwenke, and today I will be discussing Kirchhoff's laws. The laws that we will be discussing were developed by Gustav Robert Kirchhoff. He was a German scientist that further developed our understanding of complicated networks based off of George Ohm's findings. Kirchhoff first described his laws in 1845 and found them to be applicable to both DC and AC circuits. The first law that Kirchhoff developed was his current law. This law stated that the algebraic sum of the currents entering any node is zero. From that, we get the equation for KCL, which is shown here. And so let's take a look at an example to see how this first law is used. So for this example, we have each node numbered, and we have the equation for each node placed in number order 1 through 5. For now, we're going to assume that the currents leaving the nodes are positive. So for the first node, we have I1 entering the node, and I2 and 3 leaving the node. So remember, the currents entering the node are negative, and the currents leaving the node are positive. So for node 1, we get the equation negative I1 plus I2 plus I3 equals 0. Every equation is set equal to 0. So for node 2, we have I1 and I6 leaving, and we have I4 entering. So we get I1 minus I4 plus I6 equals 0. Continuing for node 3, we have I2 and I5 entering, and we have I4 and I7 leaving. So we get negative I2 plus I4 minus I5 plus I7 equals 0. For node 4, I3 and I8 are entering, and I5 is leaving. So negative I3 plus I5 minus I8 equals 0. Then finally for node 5, I think everybody got the hang of it, and we get negative I6 minus I7 plus I8 equals 0. Pretty simple. Kirchhoff's second law is the voltage law. It says that the algebraic sum of the voltages around any loop is 0. So, a lot like his first law, except it deals with voltages in a loop instead of currents in a node. And in the first law, the algebraic sign was used to keep track of whether the currents were entering or leaving a node. In KVL, the sign is necessary to keep track of the voltage polarity, so we can determine whether the energy level is increasing or decreasing as we go through each element. But overall, we get the equation, the sum of the voltages is equal to 0. So if we take a look at a simple example of KVL, you can see that we have two equations. There is one equation for each mesh. For the first mesh, we have the flow of our current going clockwise. Because the flow is clockwise, VR1 and VR2 are positive, and VS is a negative. So you get the equation VR1 plus VR2 minus VS equals 0. Again, everything is set equal to 0. Then on the other side of the circuit, there will be a different equation. For the right side, the flow is clockwise again. So you get 20 VR1 and VR3 to be positive, but this time the flow is going in the opposite direction of VR2. So you must remember that just because an element is positive or negative in one equation, the signs may flip for a different equation. So in this case, VR2 is negative, and we get the equation 20 VR1 plus VR3 minus VR2 equals 0. So to finish off, just a quick summary of what we went over. Kirchhoff's current law is the sum of all currents entering a node is equal to 0. Kirchhoff's voltage law is the sum of all voltages around any loop is equal to 0. And these laws will help simplify the calculations of complex circuits, and your knowledge of them can benefit you as you move forward into the engineering and electronics workforce. And here are my sources. Thank you.